industrial world, you have a lot of processes that involve a lot of dependency, right? In manufacturing, probably a single SKU, it can take 30 different processes and steps. And of course, that's just for a single SKU, and you can have different kind of products that company produce, different kind of equipment that it involve. Some are new, some are old, some are from different brands, from Japanese, some from the Germans, some from other parts of the world. And it's very hard to bring them all onto the same platform. Well, it is possible, but then the next problem is the cost. Because to be able to service and integrate different kind of technology all together onto the same platform, that's going to cost a lot of money. Right? So that's why a lot of companies, while they know it's important, very few people can really take real actions that bring to it. We start with the problem, and the problem often starts with finding the right data and making sense of the data and making it in a timely manner, because the data gets stale very quickly. If you can measure something but you only know at the end of the week, it's no longer important. You cannot take action fast enough. So a lot of this were very human intensive, a lot of resource required to generate high quality. But at the same time, we realize it's actually very simple and efficient to do it if you use a software, if you use hardware that's purpose-built stuff. Think about it this way, there's many ways you could digitalize operation. There are ways that are very expensive. They involve open heart surgery. You might have to reprogram your machine or throw away the old one, buy a new one, or you need to lay very heavy and expensive infrastructure change. But we didn't like that. We think that it could be done easier through a wearable like a Fitbit, right? And that's why we started. It's really like a Fitbit but for machines. You know, Fitbit is for human, and what it does is it measures the steps, the heart rate, and the sleeping pattern, right? That's for human. But we do the same but for equipment, right? And when we talk about steps for equipment, we are talking about the cycle count, the number of units of goods that goes in, number of units of goods that comes out, and what is the timestamp of every single piece, right? And from there, you can actually measure and track productivity parameters. How long was the stoppages, how long was the changeover, etc. There's a lot of things you could measure for that, for productivity purpose. But at the same time, you can also measure heart rate, right? Heart rate for a machine really refers to the RPM, to the Mertot, what's the current, what's the humidity, what's the temperature. And you can tell whether a machine is going to have a heart attack soon, and you have to do something to prevent that from happening. Or at the same time, you sometimes use that to improve the quality of your product. And that's why we have built together a kit, like what we have here today, which is essentially like a Lego set. If you think about it, this is a device that we can install onto a machine, sometimes as simple as connecting 3 wires, 2 for power supply, so that it runs on its own maintenance free. And at the same time, you can connect to any kind of sensors that matters to your operation. So it's a very small device, the size of a matchbox. We try very hard to fit it as small as possible so it can fit into the smallest machine. To be honest, I'll be very frank, a lot of startups don't like to go into the world of hardware. But we soon realized that actually the first step that we need to do is the hardware layer. How can we connect to a machine? And how can we talk to it in a very efficient, very cost-effective, fast and scalable manner, so that companies can adopt it and run with it. Together with my team, we actually put together a lot of time to start with the hardware, because we sourced all the hardware that we could around the world off the shelf. We couldn't find something that really could meet our purpose, and we bite the bullet. We spend some time, develop the prototype, test it, reiterate it, and finally test and certify it. And from there, we actually moved to the next layer, which is the radio mesh network, the gateway, the Apache pin pipeline that pipes it to the cloud, as well as the analytics that we run in the cloud, the stuff at the back end, as well as the front end stuff, and all the way to the front end user visualization, the UX, UI. So we actually had a very, very long stack that we had to cover. But at the same time, it's very fulfilling because you get to have the ability to see how, from the edge of the network all the way to the user itself, be it on a computer, a dashboard, iPad, or a mobile device, how this whole thing works and integrate together. So when we talk to investor, we talk to VC and all those things, they always give this very good advice. They say, Sam, try to build a product company, not a service company. We try very hard not to go into that model where we have to customize for every particular customer. And we try and, as far as possible, build a product that users can use themselves.